Hey everyone, good morning. Dijish here from AWS User Group Kochi. On behalf of UG Kochi, let me welcome each and everyone who is joining this live stream and watching this video later on YouTube. Let me pull the agenda for today's meetup. Yeah, today we have one technical session by Vishnu Prasad. He will be talking us about one second, sorry. Yeah, he will be talking us about load testing the serverless applications and he will also walk us through the process how the Lambda scale behind the scenes. Uh, he is a serverless developer at Serverless Guru, and he is an active community member in the serverless community. He is an AWS community builder. Uh, we are happy to have you here, Vishnu. At the end of the meetup, at the end of the session, we can have a small Q&A with the speaker. If you have any comments or suggestions or questions, please put it in the YouTube comment box. We will share it with the speaker. Now, let me welcome Vishnu to join this live stream. Or to you, Vishnu.
Hey Dijish,
Hey,
thanks for the opportunity to talk in this session. And yeah,
let
so you
me
can
add your
start.
screen.
Yeah, yeah. So you can start, right?
Yeah,
And hope everyone can see my slides.
yes, we
All
can.
good. Okay, so let's start. So today's session is load testing serverless application and understanding how Lambda scales under different uh, traffic and loads. So a quick introduction about me. So my name is Vishnu Prasad. I'm a serverless developer at Serverless Guru, and I started using serverless around like 2017. Since then, I worked on multiple serverless applications, fully serverless applications in different domains, including OTT, e-commerce, IoT, ARTEC, etc. So I'm a big serverless fanboy. So I'm an occasional blogger, and I write blogs at my personal blog, which is vishnuprasad.blog. You can find my blogs there. And I also write at dev.to/imiwish. And you can reach out to me at Twitter at the below address. So a little bit about the company which I work for. So I work for a company called Serverless Guru. So what we do is we help companies uh, bring their existing stack, migrating their existing stack to serverless. Also, we help companies to create new application uh, from uh, uh, from scratch, serverless application from scratch. And we are a group of serverless enthusiasts there, enjoying do serverless development and architecture. And on today's session, we'll be covering these 4 points. So first, we will try to do some understanding of a quick understanding of what is a load testing and the load testing tools, how we do load testing, and we also discuss do a simple demo, like a 5-minute demo of doing a load testing of a simple serverless application, and then we will try to understand what is Lambda concurrency. Then we will go through some load testing results which we did previously, and we'll show you how Lambda scales and under different loads. So the first thing, load testing. So you might have heard about what is a load testing, but what a load testing is. So load testing is something you suppose you have a new application, or your application has a new feature. You want to test it with the real traffic. So you want to know how your application performs under different loads and all. So that's where we do load testing. So suppose you create a new development environment and you deploy your application there and you generate some massive amount of load, then you will see the metrics of the application and see how the application works. So why load testing? So when you do load testing, you will get to know some information about your application, something like how fast is the system and how much load can the system handle and under what condition will the system fail. And it also helps us to find response times for your APIs, CPU and memory utilization, and latency, etc., under different loads. So this is the basic of load testing and why should we do load testing. And how do we do load testing actually? So there are like a lot of tools in the market which helps to do load testing. The most commonly used load testing tool which I know is JMeter, Locust, and Artillery.io. So all three of them has kind of similar features. Some of them has additional features. Some of them has nice GUI, and it has some nice plugin support, community support, and etc. Some of them are like just command line tool, and that's it. So when you do load testing with these tools, so these tools we install on our local machine, and we set some configurations. We set some configuration, and we ask these tools to do a load, generate a load against your target application or API endpoint, whatever. So when we do it with your laptop or PC, there are some limitations for these applications. The maximum amount of load these tools can generate is limited to the configuration of your laptop or PC. So if your laptop has like 4 gigs of or 8 gigs of RAM, and when you try to generate like the maximum amount of traffic with that configuration, you can generate this maximum of like 1,000 concurrent requests per second, or like 2,000 maximum. So it's because when it generates that kind of load, the CPU and the memory utilization goes to 100%, then this application will start to fail, start to crash. So then if you want to create like high amount of load, like 10,000 or 20,000 requests per second, you won't be able to do it from your laptop or your local machine. You would need a real workhorse with like a pretty high configuration, like 64 gigs of RAM or something like that, 32 or 64 gigs of RAM. So that's a bit costly to have such kind of setup. And but how do we do with that without spending much money on the a workhorse machine or something like that? So the answer which I found was there's a tool called Serverless Artillery, and let's see why it is different, how it is different. So serverless artillery is a combination of serverless framework and artillery.io, which is the tool which I showed here. So this is the tool artillery.io. It's a command line tool, simple npm module. And let me see if I can get pointer. I cannot see. Okay. So it's a combination of serverless framework and artillery.io. So you guys already know what a serverless framework is. So serverless framework is a framework to write Lambda functions and create serverless architecture, serverless deployments. And so it's a combination of serverless framework and artillery, and it is completely serverless. And this load testing tool runs on Lambda function, and it can generate massive amount of loads with simple configuration. You don't need a laptop. You don't need a big workhorse machine with like large configurations and all. What you need is a simple laptop with the normal configuration. Let's see how it works. So you install the serverless artillery. It's a simple command line. So you install it using npm install serverless artillery in your local machine. Then you write some symbol configuration in a script.yaml file. And then what you do is you deploy with a simple command called SLS deploy. When you deploy it, it creates a Lambda function in your AWS account, which is called a load generator Lambda function. Then you write the configuration which you want for the load testing in your local machine with the script.yaml, or it can be any name. And when you do SLS invoke and argument your script file, the configuration file, this particular function in the AWS account will create multiples of instances of Lambda functions, and it will create load against your target. So if we specify in the load testing saying that I want 100 concurrent users, so the Lambda will spin up whatever containers it needs to generate 100 concurrent requests, or if it's 1,000 or if it's 10,000, whatever. So the Lambda will spin up as many containers to generate that kind of load and generate the traffic against your test target. So let's do a quick demo on how to do a simple load testing and see the output of the load testing of a simple application with serverless artillery. I hope everybody can see my code editor. DJ, let me know if people cannot see it. I can zoom it up.
Yeah, we can see it.
See it, right? Okay, cool.
Yeah.
So this is a simple serverless application. Simple means very simple application. Simple get endpoint, get API endpoint, which we created using a serverless framework. So it has a Lambda function attached to simple Lambda function called get item, attached to an endpoint called get item, API endpoint called get item, and it has a DynamoDB table. So when user request hit the endpoint, the Lambda function will read some info from a DynamoDB table and return to the user. So so this is the endpoint that we are going to load test. It's a simple get endpoint. So when you call this endpoint, it will return with a simple message called, "Oh, serverless is amazing." So we are going to do a load test against this particular application. Now, so this is our application configuration. This is the application code, basic code. And under there's a folder called load test. Inside this, we specify the load testing configuration for our endpoint. So if you see this configuration file, you can see there are different parts. There are like config, there are like scenarios, there is flow, phases, etc. So in this target section, we add the endpoint where you want to do the load testing, which is the API endpoint which I showed earlier. And the duration, we in the duration section we mentioned for how long this load test need to be run. And arrival rate. What arrival rate is, uh, how many requests will be sent to the endpoint. How many requests will be created every second? So you mentioned we mentioned 1,000. So every second, let's put it 500 maybe. Uh, so every second 500 uh, users or 500 user requests will be created for the duration of 60 minutes, and it will try to ramp up to let's put it small 5,000. So the maximum load this load testing can generate during this 60-second period will be 5,000. Sorry. Now we can start the load testing with this particular command, SLS invoke stage and region, because I deployed the load testing function in this particular region. So when I do start, it should create a load test, start a load testing. Oh, okay. Right. I missed the AWS credentials. Okay. So when we run this command, the Lambda responded with some message saying that it has started some load testing with the configuration that we mentioned here. Now let's see the traffic which is coming to the application. For that, I have created a simple CloudWatch dashboard. So let's keep walk through the uh, dashboard. So in this dashboard, we will get some info about the API gateway Lambda function, something like API, the number of API gateway requests received in particular period, the number of 400 errors received, number of 500 errors received, number of Lambda invokes, number of concurrent Lambda concurrent executions, and the number of Lambda throttled and the duration metrics. So you can add many metrics that you need for your application here. So maybe you can add API gateway latency metrics and all other like API gateway throttling metrics, etc. here. So now if you see here, it started plotting some uh, infos here because we already started the load testing with the serverless artillery. So serverless artillery invoke the Lambda function in the region in an AWS account, and that function is sending traffic to the API gateway endpoint. And here we go. Want to see some, okay, this is a bit slow, so it will take some time to populate the data for the API gateway. While we waiting for it, we can look at the Lambda metrics actually. So during the time period like 11:13 to around 11:14, something that's a 1 minute that we mentioned on the configuration file. So it generated some traffic. So as you can see, it had like 16K Lambda invocation and 1,000 concurrent executions. Lambda throttling metrics. It's giving us Lambda duration metrics. And let's see if I have API gateway. Yeah. So API gateway is the endpoint where this Lambda, the load generator Lambda sends the traffic into. So for the 60-second period, it generated around 135K requests per minute. It's actually the amount that you see here is an aggregate of 1 minute, not a second. So this is 135K by 60. So it generated around 2,250 concurrent requests against our application. So what we did is we wrote some simple configuration file on your laptop, and when you run it, it just created like a massive amount of concurrent requests to your application. So which means you don't need with serverless artillery. The beauty of serverless artillery is you don't need a big workforce machine to generate traffic. You just only need a simple Lambda function and 5 lines of code to generate a huge amount of traffic against your application. So this is how we do basic load testing. I'll go to the configuration once more, and we specified 60-second and arrival rate we set to 500. We set the ramp up policy to 5,000. So it can be any number. You can add different kind of scenarios here. So you can suppose, for example, you can mention something like okay, I want a warm up phase. During the warm up phase, I need the arrival rate should be 100 or 200. And once the application is formed, the next phase should be like, I don't know what to call. So on the next phase, you mentioned like, okay, I want the arrival rate to be increased to 2,000 or 5,000. So you can understand how your application performs under different loads, and you can create a CloudWatch dashboard or any other graphing tools that you use like Grafana or Prometheus or whatever. You can use them and measure your application performance there. So that's the basic of uh, uh, load testing with serverless artillery. So the next topic, which is the important topic I wanted to talk in this session, is how does AWS Lambda scale? Okay, so when I was a beginner with serverless, I thought Lambda is serverless, and as AWS says, it's complete serverless. There is no servers. You don't have to manage any kind of uh, or patching or scaling. So it scales itself. You just write your code, you deploy your code, you think about only about your code and application stability. AWS will handle the scaling, and it's always, and also it's like a paper model building. So don't worry about scaling. So at Serverless Guru, we decided to do uh, an experiment actually to understand how Lambda will uh, perform under different loads. So all the applications we have created so far was like less traffic applications. The maximum we had was like 100,000 requests per day. So it was like less than 20 or 50 requests per second. So Lambda was able to process them without any issues because the traffic is very less. So we created a simple application. This is the same application that I showed in the load testing demo. So there is an HTTP request which goes to an API gateway endpoint and which goes to a Lambda. Lambda then sent to then reads the DynamoDB based on the request and returns some data to the requestee. So this is a very simple HTTP endpoint. So we tested with this particular application, and we did our first test. And the first test was we used serverless artillery, and we put the endpoint detail here, and we set a duration of 5 minutes and set the arrival rate to 500, and we tried to ram the traffic to 10,000 requests per second, concurrent requests per second during that period, the maximum. And let's see what was the output. And we were expecting we will be able to serve all the requests that we sent. So as you can see here, this is a CloudWatch dashboard similar to the one that I showed. It has the API gateway metrics, Lambda metrics, DynamoDB metrics, etc. So during our test, this application created the load testing Lambda function created around 475K, which is around 6,000 requests per concurrent requests per minute. Sorry, second, 6,000 concurrent requests per second at one point around this time. And you can see there was like 100K invocations. There are like 1,000 concurrent invocations, and some 4x, them 500s, some throttling in first TTP rate, etc. So important widget to see is this one. I don't know why I'm not able to see the pointer option. Anyway, so if you see here, if you can see my mouse pointer, the concurrent execution metrics. At one point of the load testing, this graph started to go in linear, which is like once it reached 1,000, it started to go in linear. So at the time it hit the 1,000 concurrent execution, you can see here in the throttling graph, Lambda started to throttling request. So around 6,000 requests, around 4,500 or 5,000 requests got throttled, which is not what we wanted. We were expecting all to be served, right? So among 6,000, 5,000 got throttled, and we checked why. So it is because in an AWS account, in a region, there is a soft limit called regional concurrency limit set by AWS. So in a region, the concurrency limit is the maximum concurrency limit. It's a soft limit, which is 1,000. So in every region, it varies per region actually. For US East one, it is 1,000. So if your Lambda function gets like uh, 2,000 or 3,000 concurrent invocations from any of the sources, the first 1,000 will be served and others will be throttled. It's because of the soft limit. You can actually increase the soft limit to mitigate this. We will see that in a bit. So before we going to the next load test, let's try to understand what is a Lambda concurrency. So a Lambda concurrency is your function's concurrency is the number of instances that serve requests at a given time, which means if you look at this graph, suppose you have a function, it takes 200 milliseconds to process a request. So your function got a get request, which the function need to go to Dynamo, fetch some record, give it to the API gateway back. So that's execution time. So suppose it takes 200 milliseconds to process one request, and your function got 5 requests at a time in a second. So your function can serve all the 5 because 200 into 5 is like 1 second. 200 milliseconds into 5 is 1 second. So this function can serve uh, uh, 5 requests per second. And so the concurrency of the function will be 1. So at that given time. And the throughput is 5 requests per second. And what happens if you receive like six requests at a time? So when you receive 6 requests at a time, the function can only serve 5 requests because it takes 200 milliseconds to process one. So all the 5 will be served using the first execution context, and the 6 request, it won't wait actually. It won't wait until this get finished. Lambda will create another execution context to process that. So the concurrency of your function will be 6 at that time. Sorry, 2 at that time. Sorry. And if you see this graph, this is a graph from AWS, which explains the throttling and everything. So you have a region, you're in a region called USS1, and it has a regional concurrency limit of 1,000. And suppose your function take more than 1 second to process one request. So if you receive 1 request per second, your concurrency is 1 at that time. And if you receive 1,000 requests for that particular function, all the 1,000 will be served without an issue. We're talking about a single function. And this concurrency can share across multiple functions, but we are talking about talking about only one function. So it will only if you receive 1,000 requests, will be fine. All 1,000 will be served at a time, and because the function take 1 second, so 1 into 1,000 is 1,000 concurrent execution context. But when you get a burst of 4,000 requests to a function in a second, what happens? The 1,000 is served, 3,000 is throttled. The next minute, your function started to get the same amount of traffic every second for 1 minute, 2 minutes, 5 minutes, 3 minutes, whatever the time period is. Only the 1,000 function, only the 1,000 requests will be served, and 3,000 will be throttled. So this is because of the soft limit. So this is the first limit that we saw. Then we decided to increase the regional limit. So we created a support ticket and asked AWS saying that, okay, we are doing load testing. We have an application which will receive a huge amount of traffic when we go live. So we need to do a load testing. So for that, we need to um, increase the regional concurrency limit. So we requested for 30,000 requests per second, and the approved that we got was 20,000 requests per 20,000 concurrent execution context, which was fine. And we set up our second load test. We put an endpoint and we set the duration to 15 minutes and set the arrival rate to 2,500 and set the ramp up configuration to 10,000. So during the 15-minute period, it will try to create a traffic up to 10,000, up to 10,000 concurrent requests. Let's see the results. So same graphs again, but different metrics. As you can see here, this function created like during the 15 minutes period, 30, 20, 30, 23, 13 to 23, 45, it created around like 560K, which is 560K, 60K by 60, around 9,300 concurrent requests. And we were expecting this will be served without any issue. As you see here, this particular traffic, this particular metrics, concurrent executions of Lambda, at one point when it reached 3,000 concurrent execution, you can see Lambda started throttling some requests, not all of them, some requests got throttled. And you can see the concurrent execution going up, but throttling, the concurrent execution is going up because we have it increased to 20,000. But the throttling started at 3K, 3,000 concurrent execution. And we didn't understand why. So we looked into the documentation and we found out, okay, there is another set of limits which AWS has put at region level, which is called burst concurrency limit. So what burst concurrency limit is? For an initial burst of traffic, your function's cumulative concurrency in a region can reach an initial level between 500 and 3,000, which varies per region. So this limit is set to 3,000 in US East region, but this limit is will varies per region. If you take Mumbai, the burst concurrency limit is 500. Let's try to understand how that is. So you take the same set of lambda function, this is a single lambda function, and it takes like more than 1 second to finish one request, and you receive 1,000 requests all served. You receive 4,000 burst. So the 3,000 served, 1,000 throttle is because of this burst limit 3,000. But it won't throttle all the requests in the upcoming minutes. So what happens? So you continue getting 4,000 requests every second until the next minute. So in the next minute, Lambda will add 500 more execution context to a Lambda function, which means every 5 minutes. So in this case, uh, you continue getting 4,000 requests per second. And in the first minute, you got 1,000 throttle, but in the second minute, it added 500 extra execution context, which means you have now 3,500 containers execution context up and running. So 3,500 out of 4,000 will be served. Only 500 will be throttled. So the next in the next minute, so you keep continuing with this same rate, 4,000 requests per second, and the next minute Lambda adds 500 more containers or execution context to the function. At the second minute, all the 4,000 requests will be served. None of them will be throttled. Then this will go on like that. So if your regional concurrency is like 4,000 and your application has a constant 4,000 concurrent request, all will be served in after 1 minute. So it means that when you get a burst topic, all of the requests will not be served quickly, but gradually it will serve. So Lambda needs some time to scale things up, which is 500 containers per minute. So that's how Lambda scales when you have huge amount of traffic. So this is an issue, right? So all the requests will be throttled, but your application cannot accept that. So there are like different architecture patterns. You can mitigate that. Like for example, you can set up like a retry mechanism on the client side, or whatever the source which invokes the Lambda function, and you can put queues in between Lambda and the source or whatever, and so on so on. So there are different architecture patterns. So that will be a complete that will be a talk for a complete new session, because there are a lot of patterns to uh, discuss. So what we understand from these two tests is we have like Lambda has two type of limits. So the first one is the regional limit, which is a soft limit, which can be increased upon a service quota increase request. And the second limit is the burst limit, which is a hard limit. There's no option we can ask for a quota increase for that. So you need to design your application to handle throttling so that your application won't drop any kind of request. So another question came to our mind is how do we process all these requests without any kind of throttling and um without any architectural change or patterns. So at the same time that we are doing this load testing, there was something launched called provision concurrency. You guys might have heard about provision concurrency and Lambda function. So what is provision concurrency? So provision concurrency launched in 2019 reInvent, and provision concurrency initializes a requested number of execution environments so that they are prepared to respond to your function invocations. Which means, suppose you have a Lambda function which does very critical task in your application, like a payment processing or order processing, which which cannot be failed at any given time. So you can tell this you can tell in AWS, you can console, you can go to the console and say, I have this function, and please put a particular number of Lambda execution context or containers keep up and running for this function for a particular period of time. So you can go to the console and you can mention an amount of provision concurrency in your for a particular Lambda function. So suppose you mention 100, the number 100, what happens is this particular Lambda will have 100 containers up and running all the time. So if you put 5,000 provision concurrency, there will be 5,000 containers will be up and running for that particular function all the time. So if you receive a burst of 4,000 for that particular function, all will be served at the very moment without any throttling or cold start and all. So cold start, you guys might know what cold start is. So cold start is something which is all the Lambda function, all the serverless application Lambdas has. So when a request first comes into Lambda function, there will be no containers up and running. So when the first request come, AWS takes some time to create a new Lambda function, new Lambda container, create a Lambda container, pull all your codes for the container, initialize them, So that takes some time. So the time to initialize those creation and initialization is called the cold start. So it affects the overall latency of your API or whatever the application because of this time. So this is called cold start. So when you have provision concurrency, you don't have a cold start for the particular function because it has all the containers up and running for a given time. And there are different ways of avoiding cold start without provision concurrency. Like people used to warm up the lambdas with fake payloads and all, so which will be up and running some amount of containers all the time. And another thing about provision concurrency is the payment model, which is a bit expensive because we are running a certain amount of containers for a function for a particular period of time, which means if you provide 100 provision concurrency to a function for 1 hour or uh, 1 day, so you have to pay for the amount of time uh, it runs along with the execution price and the uh, GB used price. So what we did for the next load testing is we enabled 10,000 concurrent provision concurrency for the Lambda function for this endpoint, and we did the same load test with like 15 minutes arrival rate of 2,500 and ramped up to around 10K. Now see the results. So here, if you see the uh, graph, you will see some different matrices other than the one that you see in the previous slides. So when you enable provision concurrency, you don't see the metrics for lambdas in the normal Lambda CloudWatch metrics. Instead, you will see a different metrics for provision concurrency, which is kind of similar thing, but different names. So provision concurrency, invocation, provision concurrent execution, and spillovers for hundreds, provision concurrency utilization, etc. So for this test, when there was like it created around 550K, which is like 9,000 concurrent requests to the API endpoint. And if you see this graph, this is interesting. It is nothing is got throttled. All the 9,000 requests were served without an issue because we asked the Lambda function to have 10,000 containers up and running for some time while we doing the load test. And this metrics tell you the utilization of provision concurrency. So which means when you have provision concurrency and you specify a number of, for example, let's take an example. You have this very busy endpoint which does the payment processing and all, and you have a sale coming for your application. Suppose you have an e-commerce application and tomorrow is Diwali and you are expecting like a huge amount of traffic for your payment endpoints and everything. So uh, you can mention that, okay, tomorrow is Diwali, so we are expecting too much traffic for this endpoint. So let's add some provision concurrency so we don't get any kind of throttling or latency to the function. So we say add 10,000 concurrent requests. So during the sale period, if you receive 10,000 requests per second, all will be served without an issue. And because of this, provision concurrency is expensive, so you don't have to run the provision concurrency all the time. So there is a way you can do auto scaling for provision concurrency. So if you see this metrics here, this is telling how much of your provision concurrency was used during this period. So you have I had 10,000 concurrency and provision concurrency enabled, and 97% of the concurrency was used, not 100%. So these numbers are a bit weird, but this is how they plot the graph. So 97% of the provision concurrency was used. So what we can do is you can put your a provision concurrency of like 50 or 100 for the application and keep it running for all the time. But when you have a surge in the traffic, so you can create an auto scaling configuration saying that if my provision concurrency utilization goes more than 50%, add more provision concurrency to my uh, Lambda function. So based on that, you can add more concurrency to your function and serve all the requests. So this was our test. We tried different configuration and load testing, and we found that there was like a soft limit, regional soft limit. Then burst, there was like with regional limit, only 1,000 concurrent execution are allowed, and with the burst there will be like 3,000 limit, but it will scale 500 request containers per minute. Lambda will add 500 containers per minute. So and then we tried provision concurrency. With provision concurrency, we came to know that uh, you can serve all the requests without any throttling, latency, or any kind of issues. And you can do auto scaling for provision concurrency. Quick recap. We During this talk, what we learned. So we learned about what is concurrency. So we learned that like your function's concurrency is the number of instances that we serve request at a given time, and there's a regional limit or regional default concurrency, which limit is limited to 1,000, and there is a burst concurrency limit, which is 3,000 to 500 videos per region. Then there are like provision concurrency and how it works. So that's it from my side, and any questions, we can answer that.
Thank you, Vishnu. Let me go through the comments.
Yeah.
As a solution architect, where we can start? Can you share any tutorial link and suggestions? It's a general question, actually. Uh,
It's a kind of general question, right?
let me,
So where can you start? If it's about serverless, yeah.
Benefits of running Lambda inside VPC.
Benefits of learning. Okay, so that's VPC. If you run lambdas in a VPC, that's for to access your like uh, private stuff like um, RDS or instances. If you want all your, you will put all your databases and everything inside a VPC, right? So if you want to access that, you need to run this particular lambda inside um, uh, a VPC to access that. So the benefits will be it can be secure. It will be secure. Your databases or any other private stuff won't be compromised with the uh, outside world and all.
Okay. Actually, we don't have any additional questions. If we get anything in
Mhm.
our emails, I will forward to you.
Yep. All
Uh,
right.
I think we can wind up. Thank you very much for sharing your knowledge and in-depth explanations and demos.
Sure thing.
Thank you.
Yeah. If anyone has any question, you can directly shoot me at Twitter or LinkedIn, whatever. So thanks. Thanks everyone. Have a good weekend. Enjoy.